I don't know.
Alright, get your waves out now.
Sup?
Oh, there.
So I can edit all that out right now.
Rejected.
You can just cut out.
Alright, so for our agenda today, we have a quick warm-up, Desmos lesson 6.2a, and then you can work on your homework if we have time. So, warm-up number 13, simplify each following expression. This really should only take you about 5, maybe 8 minutes, at which time we will ask for student volunteers.
What is this?
Again, this is warm-up number 13. You may work with your tables and your tables only. I want a lot of people running around shooting chaos. Yeah, this should be relatively simple for you guys. right, let's get some student volunteers. Who would like to show number 1? Yes, sir. Just bring it up to the top. Bring it on up. Two a squared times 5b to the negative third over 12b to the fourth.
So I multiplied the ones on the top together, and I got 10a squared b to the negative 3 over 12b to the fourth. And then I put the b to the negative 3 on the bottom, and I got 10a squared over 12b to the fourth plus b to the third, and I got 10a squared 12b to the seventh, and then I simplified that to 5a squared over 6b to the 2.
Well done. Clap it up. Who's got number 2?
I see question number 3.
Can you see question number 3?
Yeah, I just copy it down.
Sure. Who's got number 2? Who's got it done and wants to share, please? Yes, run.
Okay, so it's 3x squared times 6y cubed over 2x cubed times 18y to the negative 2. So first I combine these two terms to make it 18x squared times y to the third over 2 times 18x cubed times y to the negative 2. So I saw that the 18s can cancel out. So it's just a 2 on the bottom. And then here x to the third and x squared. So the x squared cancels out and it's just x on the bottom. And I can move the y to the negative 2 up to the top. So it's y to the fifth. That's all that's left on the numerator. And 2 times x, because there was 1 x left after canceling out with the x squared. So y to the fifth over 2x.
Well done. Clap it up for Mr. Brown. And a volunteer for number 3, please. Yes, ma'am.
So it's 5x to the fourth y negative fourth over 25 of x minus 1 and then y to the second. So I brought the x minus 1 to the top and then the y minus 4 to the bottom. And then I got 5x to the fifth over 25 y to the sixth. So then we can simplify them because they both divide by 5. So then I got x to the negative 5.
Well done. Clap it up again. Any questions on the warm-up? Questions, concerns, comments? All right, let's move on. Let's open up the Chromebooks. We are moving on to Desmos 6.2a. Proof of the Pythagorean Theorem. All right. So, slide 1 opens up with this statement, correct? In the problems below, a right triangle is shown in gray. The shorter sides of a right triangle are referred to as the legs, and the longer side of the right triangle, side opposite of the right angle, is called the hypotenuse. All right, is everyone in the Desmos? Not yet? Let's give you a second to get into Desmos before we even get started. That's probably step 1. You're in the Desmos, right? You're accepting Desmos. I just checked it out. You're working on the Desmos. Beautiful. All right, it looks like the majority of us are into the Google Classroom. Maybe a few others that are still getting in. All right, so for those of you that are in, let's look at slide number 1. And know that and understand that the shorter sides of a right triangle are what we call the legs, and the big side opposite the right angle we call the hypotenuse. Okay? If you move on to slide number 2, where it should show this figure right here. Is that what everyone's seeing? Right here. Where are my legs and where's the hypotenuse on this diagram? This gray triangle in the middle. Which one are the legs? Which one is the hypotenuse? Yes, ma'am. The legs are, so this one right here?
Yeah.
All right, so that we can call that a leg. And which one? This one? And we'll call that a leg. So then where's my hypotenuse? Yeah, the opposite one here, right? That is our hypotenuse. Okay? So, the squares have been drawn adjacent to the sides of the right triangle. Find the area of each of the squares. Assume each square on the grid has a side length of 1 unit. Write the areas inside each of the squares. So, we can go ahead and just look at these squares, right? What is the area of the small squares? 4, right? 1, 2, 3, 4. Cool. We have 4 and 4. How about the large square?
8.
Right? We can count that up, right? We get 8. We got 1, 2, 3, 4, and these halves of those are halves of a square, right? Everyone see that? These are halves of a square. We have 4 sets of halves of a square. So we got the larger square is 8. Okay? So slide 3, what do you notice about the relationship between the areas of the squares formed adjacent to the legs of the right triangle? What can we conclude from this problem that we just did? Anyone? Yes. Okay. In this equation, yes, it's double. How about the fact that just small square added up together equals the area of the big square? Does everyone see that? Because how about for this one that we're not going to really get into? Does this look like it's double? Like, does this big square look like it's double? Yeah, so it's not always going to be double, but what you can notice is that the sum of the areas of the smaller squares are going to add up to the area of the larger square. So just conceptually speaking, that's how you can prove that the Pythagorean Theorem works, is that you can add up the areas of the smaller two squares, here and here, and it will equal the area of the big square. Any questions so far? Okay. So moving on to slide 4. Okay. In each of the problems below, a right triangle is shown in gray. These squares along each of the 3 sides of the triangle have been drawn. The area of 2 of the squares is given. Determine the area of the 3rd square. Write your answer in the square. Determine the value of the legs and the hypotenuse for each triangle, and write the values below each picture. Verify your side lengths using the Pythagorean Theorem. What is the Pythagorean Theorem? Does anyone know?
Plus B squared equals C squared.
Yeah, right? A squared plus B squared equals C squared. So, number 10. What is the length of our legs? Where are my legs, first of all? Yeah, we got one leg right here. Leg. Now we got another leg right there. Leg and leg. So what is the value of leg 1? What's the value of leg 1? 1. What's the value of leg 2?
6, 5, 6.
How do we, this is a perfect square, this is the area, remember. Right? So it would be the square root of 36, which is 6. Okay? What is the area of this big square right here? What is the area of that square? 1 plus 36, or that's the area. So the length of the hypotenuse, would be square root of 37. So we're going to see how we're finding those few things. And then verify using the Pythagorean Theorem. So we know that a squared plus b squared equals c squared. Okay, we have leg 1, which is 1 squared, times b squared, 6 squared, is equal to square root of 37 squared. 1 plus 36 is equal to 37. 37 equals 37. That checks out. So you can always use the Pythagorean Theorem to verify that you're doing your math correctly. Everything will add up and show that everything will be true. Questions so far? Let's do one more together, and then I'm going to have you do slides 6 and 7 on your own. Okay? So slide 5 here, we have one area of 29 and one area of 4. So what's our bigger area? Oh no, I'm sorry, I misspoke. This is not our bigger area. Where is our hypotenuse on this gray triangle? This is our hypotenuse, right? Okay. And we have a leg here, leg number 1, and we're trying to find leg number 2. So what's the area of this big square? What is the area of this other square? Why is it 25? Or why is the area 25? And then why is the side 5? Yeah, 29 minus 4, right? You get an area of 25. So our legs We have an area of 4, an area of 25, and an area of 29. What are my legs? What are those sides? What are the lengths of my legs? Yes, sir.
5 and 2.
We'll go 2 and 5. 5 and 2, 2 and 5. Yeah. And what is the length of my hypotenuse? What is the length of the hypotenuse? How long is that? Square root of 29. Thank you, Micah. So now how am I going to verify that all this is right using the Pythagorean Theorem? How am I going to set it up? Yes, sir.
A squared plus B squared equals C squared.
So what's my a squared? Right? Our a squared is one leg, our b squared is the second leg, and our c squared is always our hypotenuse. So how am I going to set this up to verify it? What's my a squared? Yes, question. Yes, one leg will always be A and one leg will always be B. No. You can really write B squared plus A squared equals C squared. It's still going to come out the same. Good question. So who wants to define my A squared? 2 squared. Thank you. We have 2 squared plus my B squared. What's my B squared? 5 squared. Radical 29 squared. 4 plus 25 29. 29 equals 29, and now checks out. Okay? Any questions? Speak now, please. All right. For slides 6 and 7, I'm going to have you do those on your own. You may work with your table groups. We will reconvene in a little bit to make sure we are doing things correctly. We're going to be doing homework. Do you have any questions on anything? You do it right? Think so? Let's see what you're I'll just be coming around the room and checking your work. Make sure you are doing it correctly.
Alright, so do you factor that? You know that these 2 areas have this area.
I'll help you on a square. I know.
Plus X.
It's 4. Because a squared, B squared. You're so doo-doo.
Or no, it would be 2 squared plus B squared.
Sure about that.
So what's the length of each of these?
Oh, did you just put a square root? What's the side?
2 and 2, right?
Yeah.
And what's the length of your
The side right here.
Yeah, squared. Square root. It would be 2.
Yeah, square root.
This?
You're so
Yeah.
smart. This is just too smart.
Wouldn't that would it?
This smart.
Does a squared plus b squared equals c squared, right? So what's the square root of 8?
How is that 2 squared? That's root 8. Root 8
Square
squared.
root 8 is.
You put it in
It doesn't have a perfect square root, does it?
No, well, what would you write it in? Write it in radical form. What would it be?
2 root
2 root 2. But all it's asking for on the slide is what questions, comments, concerns?
Oh, no.
mathematics in your notebook.
Yeah.
Where's that?
Do we do our homework once you're done? I don't print out anyway, so I print out.
Yes,
So I can't do it. Yeah, too bad. Which remote? Wait, and make 20, what's 36 plus 13 plus 9? What's the square root of 52? 7
square root
I said it before.
2 square root 13.
I need to do my English.
You're doing everything?
Wait, is it?
Next period. I didn't do it. And yeah, good. My cousins were over. They still are. Where? My
haircut control.
Yeah. How do you do 2? That's not possible. How do you do 2 root 13 squared? That's just my
We're
question.
just gonna wait to cancel it out.
Wait, I have about an hour and 50 to do mine. Yeah, I know. Did you?
The brain.
I see that. Yeah, you don't need it anyways because it'll become I don't do my history. No, we'll try to escape whoever get to level 5 first. That's not, I need to get to 7.
You're gonna be just.
How much time did you spend? 2 hours and 16 minutes. It was a Saturday morning. At 5 a.m. I was determined. I recorded it with my that company. No one. You're smart. That's what you want. Yeah. I'm proud of myself.
Shit, that is not very Wait. I am proud of myself. I am not proud of myself. Whatever, there's no difference.
Because you are.
God.
Wait.
What's my also for?
Alright, so it looks like everyone's pretty much done with the Desmos. Let's check your work. What is the area of the small square here?
4.
4. So the sides of my legs are 2 and 2. Yeah, there's 2 of those legs of 2. What is the length of my hypotenuse? Radical 8, also known as? 2 times 2 root 2. Verify using the Pythagorean Theorem. What's my a squared?
4.
Or what is my a, I should say?
2.
Yeah, this is the Desmos. What's my b?
2.
And what's my c?
Square root of 8. Yeah.
And finally, the last one. What is the area of the larger square?
52.
Definitely not nothing. 52. 16 plus 36 is 52. So what are the lengths of my legs?
4 and 6.
4 and 6 is vertical. What is that?
4 and 6. What is the length of my hypotenuse?
5.
Square root of 52, also known as 2 radical 13 in simplest radical form. Verify using the Pythagorean Theorem. What's my A? Somebody give me an A. Thank you.
Somebody give me an A.
Somebody give me a B.
6. No thanks.
There it is.
I want an A.
And somebody give me my C.
No C's for this child.
What is my C?
2 rad 13.
Thank you. 2 radical 13 squared.
I need to do a book report on this.
16 plus 36 is equal to 52. 52 equals 52. And that checks out.
The story
All right.
is so easy.
Yo, can we Pythagorean?
We just check the whole
All right, for the rest of class, we are working on your homework.
What? There's a meeting in the learning college. Just do it at Paul.
So they're not even allowing people to print out.
There's like a presentation for like where the counselors are presenting to the class.
And text them right now, just copy it up, like if someone has it.
Oh my gosh, it's so much. I
Are you sure about that?
Hey, no rainbows.
Wait, it's at 12. Yeah, I know 11:45. It's 12:55.
Thumbs on the camera.
We're gonna college.
55.
15. It's not 25. I can't do this.
JJ.
What?
16 plus
A talking shit. Impressed. I said, a talking shit.